Bismillahirrahmanirrahim. Assalam O Alikum. Dear students, welcome to my YouTube channel Learn with Azam. Today we will discuss about new syllabus Physics SSC2 Unit number 11 Sound. We will discuss about SLO base according to FBISE requirement numerical problems. Today we will solve question number 9 to 12. In previous video we can solve the numerical problem question number 4 to 5 to 8. In this video we can solve 9 to 12. So, in numerical problems, question number 9, what is the speed of sound in air at minus 20 Celsius? So, write the given data, temperature T is equal to minus 20 degrees Celsius and required that speed of sound V is equal to question mark. Now we can find the speed of sound using the formula V is equal to 331 plus 0.6 multiplied by T. So we have putting the values Vt is equal to 331 plus 0.61 T. Putting the value of temperature, then Vt speed of sound at temperature T is equal to 331 plus 0.6 into minus 12. So minus 12 multiplied by 0.6, that is equal to minus 12. So 331 minus 12 is equal to 319. So the answer of this question is 319. Now, in question number 10, army men wear a binoculars see the fish from enemy. Tank fire the 5 seconds before the fire of his hair. He records 26 Celsius temperature on his personal thermometer. What is the distance of tank from him? Now write the given data. Time T is equal to 5 seconds and temperature T is equal to 26 Celsius, and also we require that distance of tank, that is equal to S. Now we use the formula S is equal to Vt. Here V is the speed of sound at temperature T. So we have S is equal to 331 plus 0.6 multiplied by T into multiplied by time. Now we have putting the values, then S is equal to Vt is equal to 331 plus 0.6 into temperature T multiplied by time T. Now S is equal to Vt, putting the values S is equal to 331 plus 0.6 multiplied by 26 into multiplied by time 5 seconds. So 0.6 multiplied by 26 is equal to 15.6. So adding 331 plus 15.6 multiplied by 5. Then answer is 1733 meters. So the distance of the tank is 1733 meters. Now we can find the other numerical. Question number 11. Calculate the wavelength of a sound at the extreme of the audible range 20 Hz and 20,000 Hz at normal temperature of 20 Celsius. Now, first of all, frequency of first sound F1 is equal to 20 Hz and frequency of second sound F2 is equal to 20,000 Hz. Temperature T is equal to 20 Celsius. Now we have required that wavelength of first sound and wavelength of second sound. So using the formula V is equal to F lambda. Rearrange the formula, then lambda is equal to V upon F. Here V is the speed of sound at 20 Celsius. So using the formula lambda is equal to 331 plus 0.6 E divided by F. For solution, putting the values, then first of all find the lambda 1 wavelength 1. So V lambda 1 is equal to V upon F1. That is equal to lambda 1 is equal to 331 plus 0.6 multiplied by 20 divided by 20. So 20 multiplied by 0.6, that is equal to 12. 331 plus 12 is equal to 343 divided by 20. So the wavelength of F1 is equal to 17 meters. Now calculate the wavelength lambda 2, that is equal to V upon F2. So equal to 331 plus 0.6 into 20 divided by 20,000. So 20 multiplied by 0.6 is equal to 12. So 331 plus 12 is equal to 343 divided by 20,000. So the lambda 2 is equal to 0.017 meter. Today last numerical number 12, it was stand between the two high-rise buildings A and B such that he is at 33-meter distance from a building A. He below the vestal, he hear the first echo after 0.2 seconds and second echo after a 0.8 seconds. Calculate the speed of sound and distance of building B from A. Now, given data, distance is equal to S1, that is equal to 33 meters, and time of first echo, that is equal to 0.2 seconds. Now, time of second echo T2 is equal to 0.8 seconds. We can calculate the speed of sound V and wavelength of the sound distance building S2. Now we have using the formula, first of all the time is echo, so time of half sound distance, that is equal to T is equal to T by 2 and distance S is equal to Vt. So first of all find the speed of sound S, time of first echo T1, then T1 time taken of the echo reach the building A. T1 is equal to total time of T1 divided by 2, that is equal to 0.2 divided by 2 is equal to 0.1 second. And as we know that S1 is equal to Vt1, and putting the values V is equal to S1 over T, that is equal to 33 divided by 0.1, that is equal to 330 meter per second. Now time taken by the echo reach the building B, T2. So T2 is equal to total time of T2 divided by T divided by 2 is equal to 0.8 divided by 2, that is equal to 0.4 seconds. Now we have S2 is equal to VT2. So S2 is equal to 330 multiplied by 0.4, that is equal to 132 meter. So the answer is 132 meter. Best of luck in many videos with many questions. Allah Hafiz.